Welcome back to the Funny Math Teacher, where papers fly all over the place. Alright, so I'm going to get that one out of the way so I can see my next prompt. Expectations. Remember, these are notes to your future self, and this is a huge unit. So there are more resources on my website, and here are the all overarching unit objectives in general. Today we're going to move to the second one, but we're just adding and subtracting. After that we'll do some multiplication, but right now we're just going to stick with adding and subtracting. So make sure that you have your pluses and minuses all in a line, and we are ready to go. So let's pull up that video monitor. There we go. So we are on page 41. It is only one page, adding and subtracting polynomials. Everything here is actually only one page until we get to simplifying radicals, but technically the simplifying is one page and the operations is another. So it kind of works out. All right, so adding and subtracting, page 41, 42, 41. So we're going to do addition on the top half of our paper, and then we'll move into subtraction on the bottom half of the paper. So you already know how to do addition, right? So we're just going to see how it works using polynomials, and I am going to have one example for each of these. That's it. So we're going to do steps, common mistakes, and then one example. So here are the steps. We're going to go over common mistakes, so things to look out for and catch yourself on, all right? Then we're, I guess I'll wait a while. Okay, so our first step is going to be distribute the 1 and, yeah, I guess there's two ones. 1 and 1, i.e. drop parentheses. Okay, step 2 is to combine like terms. So remember, we used CLT a long time ago. Combine like terms. Remember, they have to have like variables and they have to have like exponents. If they do not match with the variable or the exponent, they are not like terms and cannot be combined. All right. So we're going to work through the example, and then I'll come back up and show you the common mistake now that you've actually seen an example after that. Okay, so it's going to take a huge long lineup. That is the one downside of polynomials. They take up a lot of room to write, especially with a marker. Okay, so pause that, write that down. So we are now going to distribute the 1 and the 1. What that means is that there are invisible positive 1s in front of each of those parentheses, or these quantities, or these polynomials. All right, so those positive 1s. What is 1 times 5x to the 4th? Still 5x to the 4th. What is 1 multiplied by 6x cubed? Still 6x cubed. 1 multiplied by negative 5x? Still negative 5x. 1 multiplied by negative 6, still negative 6. So multiplying by a positive 1 does nothing. It doesn't change anything. It's still whatever it was, which is in essence like dropping the parentheses. So we could rewrite this and just drop the parentheses. That is not going to be the case in subtraction. So that is a special circumstance for addition. Notice that I changed this negative sign into a subtraction sign. That way I can see it. Otherwise, you can put plus negative 4. That's totally fine. Okay, now we're going to combine like terms, and remember they have to have like variables and like exponents. So I'm going to look, okay, so I have an x to the 4th. There's another x to the 4th. I have an x cubed, an x cubed. I have an x to the 1st. None of those. I have an x squared. I have a negative 6 and a negative 5. Both are constants. So I've marked these out so that each of the marks are now like terms. I know to combine my two circles, so that makes 1x to the 4th, which I don't have to write that one. You can, but you don't have to. It can be invisible. I'm going to cross them out as we go. X cubed, so minus 3x cubed. X squared comes next. Remember, I'm doing standard form. I'm going from the highest degree of that 4 and working down. So it's 4, 3, 2, 1 is next. And then 0, which is made of my constants. So I get that. This is my final answer. All right, box it. That's as simple as it gets. This is not an equation. We're not solving it. Solving it comes in Algebra 2. Quadratics is in Algebra 1, but polynomials, that's Algebra 2 or beyond in college. So this is getting you familiar with it so you're not totally blown out of the water when we need something that is cubed, like volume. Okay, so common mistakes would be not keeping the same exponent. So your reminder is to keep the exponents. So notice when I was combining my like terms, I took this 5x to the 4 and minus 4x to the 4th. I combined them to do 5 minus 4 equals 1, but I kept the x to the 4th. So if it helps, think of this as 5 apples and negative 4 apples. You owed somebody 4 apples. You're left with 1 apple. But the apple is the unit, so it stays the same. It remains no matter what. You can't owe somebody something and have your apple turn into oranges. So this x to the 4th must stay the same. It's the coefficient that's changing, but the actual variable and exponent does not change. All right, so subtraction is next. Again, we'll have steps, and then we'll have our common mistake after we do our example. So this time we are going to distribute a positive 1 and then a negative 1. So it's going to look similar to addition, but not quite the same. And then after that, we are going to combine like terms. So make sure that it's also like variables and like exponents, just like we had up in the addition. Since this is notes, I'm going to rewrite that. Okay, and like means same. So if you want to say same variables, same exponents, that's the same thing. That's a like. Like. It's a like. Yep, there we go. All right, so our example. And again, I'll write this and then have you pause so you can write this down. There you go. All right, pause, write it down. Great, you're back. So again, we have an invisible 1 that's positive in the front of this first quantity and an invisible negative 1, but we see the negative part, we just don't see the 1 part. So when I distribute this positive 1, again, nothing happens. So for the beginning quantity, it is the same as just dropping parentheses, but on the second quantity, everything's going to change. So what's negative 1 multiplied by 6x cubed? It's the opposite of 6x cubed. What is negative 1 multiplied by negative 3x? It's the opposite of negative 3x, so it's a positive. And negative 1 times 9 gets me a negative 9. So notice how all the signs changed because of that negative 1. All right? So that negative 1 means the signs change on the second quantity, but the positive 1, all the signs remained the same in the first quantity. Now I'm going to combine like terms. So I got I have an x to the 4th. None more. X cubed, no more. X squared, no more. X's, and then constants. Okay, so only 2 sets of like terms. I'm going to get 8x to the 4th minus 6x cubed minus 2x squared plus 6x minus 5. So notice that we are writing this in standard form. We're starting with the largest degree. 8 is our leading coefficient because once it's in standard form, everybody's answer will look the same because we all have the same x to the 4th term. We all have the same x cubed term. We have all the same quadratic and linear and constant terms. All right, that's where all these words and vocabulary are coming back out. And then our common mistake is not distributing the negative 1 all the way. So people stop. They would just do the negative 6x cubed, but they would keep this as a negative 3x and a positive 9. That is incorrect. This negative 1 gets distributed to every term in that quantity. So make sure this is your time to remind yourself, and hopefully you listen to yourself in the future. Distribute all the way. Make sure you are distributing that negative all the way through. You're not just stopping at one of the terms. All right, so that was it. And getting our comprehension questions up. So yes, these are the same for the whole unit. You can, why should we name polynomials? That one was from last time. And there we go. And you could start thinking about why x-intercepts are such a big deal. Like, what is an x-intercept? What's a y-intercept? Why would x-intercepts be more helpful for a function than a y-intercept for a function? And think about that in the terms of polynomials have lots of x's. So they have more x's in input locations than they have an output. Most functions would. You're putting lots of things in one thing, but can be input many places, and then you're outputting just one number. Otherwise, it wouldn't be a function. So keep that in mind. We're just over 10 minutes. Thank you for coming, and have a great day.